Hi, everyone, and welcome to the Rockefeller Institute's 2021 Local Government Lab, a forum for New York State researchers, practitioners, and policymakers examining innovation and best practices in local governance. My name is Laura Rabineau. I am the Deputy Director of Research at the Rockefeller Institute, and I'll be your moderator here today. This is panel 2. If you are unaware, it's on urban sustainability and environmentalism. And this session will feature the following 3 presentations. First, Philadelphia needs a Green New Deal for transportation, presented by Emily Kennedy. Second, the open source Sidewalk, collaborating with local governments to catalyze low-embodied carbon concrete, presented by Matthew Adams and Christopher Neidl. And third, last but not least, moving toward action, closing loops city project initiative, presented by Terri Matthews and Jennifer McDonnell. Today is full of virtual presentations, so we're going to be keeping a fairly strict time limit to 15 minutes per presentation. And after every session, panelists have concluded, their presentation will then have about 10 to 15 minutes for Q&A for everybody. For those not familiar with Zoom Q&A functions, you can find the Q&A icon at the bottom of your Zoom taskbar by hovering your mouse over the screen and then selecting the Q&A icon, where you can then type in your question. So please do that as your questions arise over the course of the presentations. Before we begin, I'd just like to say a deep felt thank you to all of our panelists for taking the time to share their research and experience as part of today's forum. We look forward to your presentations and to learning from all of the work that you've already done. And with that, I will hand it off to our first presenter, Emily Kennedy, a recent graduate of the City and Regional Planning Master's Program in the Weitzman School of Design at the University of Pennsylvania. Welcome.
Great, thank you so much, Laura. I will just share my screen now. Great. Well, thank you again, Laura, and for the introduction, and to the Rockefeller Institute for having me today. I'm going to be talking about why Philadelphia needs a Green New Deal for transportation. So I hope that by the end of this presentation that I will convince you that a Green New Deal for transit is what's needed to reset the priorities and correct the imbalance that has contributed to cars being the biggest polluters in terms of greenhouse gas emissions. So the city of Philadelphia has identified this as a problem, but what they have proposed is not far enough to get to their carbon goals, especially given the current funding shortfall. And finally, these ideas are not out of reach. The city has already implemented some of them, but a more focused dedication to implementing them is needed. So the transportation sector is the single largest source of greenhouse gases in the United States, contributing to 29% of the nation's total emissions. And the majority of these emissions come from driving, specifically cars. So at 60%, cars make up the largest source of greenhouse gas emissions within transportation. And within Philadelphia, the city is no different. So why does Philadelphia need a Green New Deal for transportation? According to the City of Philadelphia's strategic transportation plan called Connect, transportation is responsible for 17% of carbon pollution in Philadelphia, the second largest source of citywide carbon emissions, just behind the housing sector. However, not all transportation is created equal. According to the city, transit vehicles contribute less to local air pollution and climate change than private automobiles. And the average greenhouse gas emissions come from cars are more than twice those of SEPTA, which is the local transit agency, Southeastern Pennsylvania's transportation authority, more than twice the current hybrid buses, and almost 3 times that of the subway and elevated rail network. So in this chart, you can tell that when it comes to commuting, Philadelphians heavily prioritize the car. So 51% of people drive alone to work and 26% take transit. However, mode choice has a clear equity implication. The majority of people relying on public transit in Philadelphia are minority populations. So 42% of Black Philadelphians and 36% of Latino Philadelphians do not have a vehicle. And this is much higher than the average for the United States as a whole. And when it comes to transportation in Philly, a major contributor to these emissions is congestion and fuel wasted searching for parking. So drivers in southeastern Pennsylvania lose approximately $1,568 a year because of congestion. 142 hours were wasted on time spent driving in congestion. Philadelphia is also the third most congested city in the country and has more cars now than any other time in its history. So when it comes to what the city of Philadelphia has done to recognize this problem, the city acknowledged cutting greenhouse gas emissions from the transportation sector as being essential to meeting Philadelphia's commitment to the Paris Climate Agreement. And Mayor Kenney, his long-term goal is, cutting carbon pollution, and so they recognize this as an issue. The city has announced that they would commit to an 80% reduction in citywide carbon emissions by 2050. And Philadelphia has proposed reducing greenhouse gas emissions from transit in several ways. So by electrifying the local transit, by cleaning Philadelphia's regional electricity grid, and by increasing bus ridership in Philadelphia. But currently the city has no plans for policies to meaningfully address the transportation sector emissions outside the city's own transit fleet. So now we'll get into the history of transportation in the US a little bit. But first, so why is the city of Philadelphia and the United States so reliant on private vehicles? What does a Green New Deal provide, and how do we get there? So a Green New Deal for transportation represents a vision that aims to put fast, reliable transit services within walking distance to as many homes and jobs as possible. And it also seeks to normalize cycling and walking as sustainable modes of transit. So how do we get there? For starters, the federal government has the money to distribute more funding for these projects to the state. It's just being spent in the wrong places. So it's being spent on highways. And that leads to the question of why Philadelphia and the US is so reliant on vehicles. So the Federal Highway Act of 1956 led to the growth of the highway system. And by linking the gas taxes to the Federal Highway Trust Fund, it allowed the government to subsidize highways. And this act also guaranteed, a steady stream of money to road building projects. So it provided 90% of funding that was used to build the interstate highway system that we have today. So to this day, while Congress continues funneling 80% of federal transportation funds into highways, only 20% is allocated for public transit. So in this graphic, you can see how 1,200 miles of transit has been created over the past decade, whereas 22,000 miles of new highways have been built over the same time period. And that's 18 miles of highway for every 1 mile of transit. So this imbalance is not going to get us any reduction in emissions. And in addition, this imbalance also continues to tilt policymakers and politicians towards favoring automobiles as the dominant mode of transit over public transit systems. And it has also encouraged land use planning and urban design practices to really give preference to the car. So in order to shift this narrative, it is necessary to fund alternative modes of travel by better subsidizing public transit instead of cars, and by investing in complete streets that ensure safe and connected bicycle and pedestrian networks. So it is also clear that funding plays a huge role in this. So before transit-oriented policies can become a reality, funding for non-automobile transportation must increase. And at a time when we know that COVID has threatened transportation agencies across the country, including SEPTA, it is even more pivotal to think about ways that we can better transition people back onto public transit. So when it comes to funding, each city and state differs in how it derives its revenue to fund its local transit agency. So in Illinois, for example, transit agencies rely on sales taxes, and in Oregon, they rely on payroll taxes to fund transit. And in San Francisco, the transit system also almost gets twice as much revenue in parking fees and fines as they do from transit fares. So there's it depends on the state, it depends on the city when it comes to how transportation is funded. But in this graphic, you can see that the Philadelphia region has a comparatively low contribution of regional funds going to public transit compared to peer cities. And this really limits SEPTA's ability to expand the system's reach, to provide better access to certain communities, and also to provide more alternatives to the car. So in Pennsylvania, much of Pennsylvania's transportation funding comes from the gas tax. However, nationwide gas tax revenues per vehicle mile traveled have declined since the gas tax was first implemented. And in Philadelphia, almost all funding for transportation comes from state and federal sources. So even if current federal and state funding levels remain the same, there's not enough funds to deliver the current projects that the city of Philadelphia has outlined. And adding to the unprecedented ridership drops from COVID, the financial viability of SEPTA is in jeopardy also because of the Act 89 and Act 44, which are set to expire in 2022. And that was a significant portion of SEPTA's budget. So I've outlined some policy recommendations that will, so before I get into the policy recommendations, the bottom line is the moment has never been more pressing as COVID-19 threatens transit agencies across the country and really unveils the deep inequities associated with our lack of investment in these systems. And so I've outlined some policy recommendations that will put Philadelphia on a path towards a greener, more equitable and job stimulating future within the transportation sector. So there are 3 policy goals. The first one is to increase revenue for public transit and complete streets projects while also managing congestion by implementing higher fees on private vehicle use. The second is to invest in transit improvements and establish financial incentives for developers to incorporate more complete streets concerns and transit-oriented developments into their required design and planning processes. And the third is to invest in climate-conscious transit and street infrastructure. So within each of these policy goals, I have a policy recommendation. So the first policy is to amend the state transportation plan to increase the prioritization of public transit funding and multimodal funds to a cumulative 60% in order to incentivize alternative modes of transit. And so the rationale for this is PennDOT projects $842 million in total transportation losses from the COVID-19 pandemic alone. And currently only 2% of the PennDOT budget goes to multimodal and a cumulative 20% to various public transportation funds. So in order to ensure the prioritization of non-car travel, PennDOT must shift the allocation of funding to more public transit and active transit modes. So the second policy is to increase ridership or rideshare fees to better incentivize public transit usage and require TNCs, which are Uber and Lyft, to disclose data on trip location. So Chicago instituted a ride-hailing surcharge dedicated to transit in late 2017, and the additional revenue was estimated to raise $21 million. So Philadelphia currently has a 1.4% revenue for ride-sharing companies, but a more equitable funding structure would be to charge 30 cents for shared trips, 50 cents for solo trips, and $1 for solo trips to Center City. And the increase in proceeds should go to SEPTA in addition to the current recipient, which is the Philadelphia Parking Authority and the school district. And rideshare companies currently also do not provide data on trips in Philadelphia. So it's really impossible to estimate what portion of trips serve low-income areas. So in order to remedy this, requiring TNCs to disclose data in exchange for their licensing requirements would allow for more reliable tracking of this data. And the third policy is to increase the cost of residential parking permits in the city. And this is because low-cost residential parking permits encourage car ownership and really undervalue the land on which parking occupies. So Philadelphia currently offers residential permit parking on select residential streets for fees ranging from $35 to $100 per car. But other cities use higher fees. And this really reflects more of the current price of the land. So Philadelphia should increase the base price for residential parking permits to $100 and tier up to $250 per car for households with 4 or more vehicles. And it should be noted that, to reflect that Philadelphia is one of the poorest large cities in the country, these increases in fees would only be applied to neighborhoods that are above the city median income level. So I'm going to quickly run through the rest here. So the 4th policy is to amend the current city zoning code to require a parking maximum policy for all new development. The 5th policy is to establish an equitable citywide congestion pricing policy. And as congestion pricing becomes a tactic used by many cities around the world to curb and deter people from driving into a city's busiest hours during peak traffic, this would be a way for SEPTA to generate money and to also mitigate congestion. Policy 6 is to establish an educational campaign on the changing parking policies to better anticipate resistance and establish community buy-in through resident engagement. So this is meant to really establish buy-in because without effective educational campaigns, resistance to these shifting policies will likely, cause outrage and hostility among local residents. Policy 7 is to develop dedicated bus lanes to move residents more quickly and efficiently throughout the city. And so the city of Philadelphia currently has plans to partner with PennDOT and SEPTA to implement the first ever dedicated bus lane, which would run along an 8-mile stretch. So this is a good first step, but this is also a necessity for prioritizing transit when we think about how to improve it in the city. Policy 8 is to incorporate a TOD district at every SEPTA station. This would facilitate, denser, more mixed-use development surrounding the station and allow, more development that would also create, better transit connectivity. And policy 9 is to establish a 100% electric SEPTA bus fleet to lower carbon emissions citywide. And this is an easy target since SEPTA has more than 90% of their bus fleet as hybrid electric. And finally, policy 10 is to incorporate new technologies and street projects such as warm mix asphalt or cool pavement to allow Philadelphia to lengthen the paving season while reducing emissions and the urban heat island effect. So a Green New Deal for transit is what's needed to really reset the priorities and correct the imbalance that has contributed to cars being the biggest polluters in terms of greenhouse gases. And the city has, identified this as a problem, but what they have proposed is not far enough. So I hope that that I provided a good snapshot for what I think the city could do to improve their plans. And I think not only does a Green New Deal for transportation for Philadelphia seek to meet net zero greenhouse gas emissions, it also aspires to tackle all forms of climate justice. And a Green New Deal for transportation in Philadelphia would provide a platform for economic, housing, and land justice, increasing the quality of life for everyone. And in order to accomplish the goals of the Green New Deal, we have to look towards the future with a systems approach that incorporates each of those things. Thank you for your time, and I'll take questions at the end.
Thank you so much for your presentation, Emily. As a former resident of Philadelphia, I can't hear the word SEPTA enough, so much appreciated. For our next presentation, I'd like to introduce Matthew Adams, Assistant Professor at New Jersey Institute of Technology, and Richard P. Nathan Fellow here at the Rockefeller Institute, as well as Christopher Neidl, the co-founder of the Open Air Institute. Welcome.
Great,
the collective, pardon me.
Okay, so are you seeing the full screen or the other one? Okay, so I'm going to talk today about our work on what we're calling the open source Sidewalk. And this is some work we're doing collaborating with local governments to try to catalyze some low-embodied carbon concrete adoption across various places in the US. So just a little introduction before, Laura just gave a good one, but I'm Dr. Matthew P. Adams. I'm an assistant professor in civil engineering at New Jersey Institute of Technology. I'm a co-director of the Materials and Structures Laboratory, where we study sustainable and durable concrete materials. So that's really the science side of what I do. The work I've been doing with Rockefeller has been on how does this actually get applied? How can we institute policies, or what sorts of policies are available to try to move us forward in terms of using sustainable concrete? And my co-presenter is Christopher Neidl, and he's the co-founder of the Open Air Collective, which is a grassroots organization that is working across the country and the world really to push policies that help to reduce carbon emissions. So what is low carbon concrete? Let's get into this a little bit. So if we think about concrete, we can think of it like it's a cookie. You have your basic cookie ingredients: eggs, flour, butter, sugar, chocolate chips, and then baking powder, baking soda, and salt. This is a basic chocolate chip cookie. If we think about what is the binder that holds everything together, it's really the mix of the eggs, flour, and butter. Our filler or flavor is our sugar and chocolate chips. And then we have modifiers that help to leaven and enhance the system. Concrete is very similar to a cookie. We have cement and water, which act as our binder or glue to hold everything together. Sand and gravel, which is our filler and flavor. It fills up a lot of space. It's inexpensive. And then we have chemical admixtures, which will help us to modify particular properties. So if we need it to take longer to harden, or we need it to stay a little bit warmer in the winter, or things like that. So that's kind of the basics of of concrete and how you can kind of think of it to something you are very familiar with. If we think about what's in concrete, this is your basic mixture. You've got some air in there, hydraulic cement, which is a gray powder that is reactive with water. You have water, and you have aggregates. The majority of concrete is made up of that sand and gravel, but really the big carbon contributor when we make concrete is hydraulic cement. So there's about 8% of the total anthropogenic CO2 output worldwide is from the production of concrete. And so that is quite a bit worldwide. And so it's really important for us to try to reduce that. Most of the CO2, and we'll talk about this in a moment, comes really from the cement portion, even though that's a smaller component of the overall concrete mixture. So why do we have so much CO2 out of concrete? Well, concrete is produced at a massive scale. In a per unit system, concrete has a relatively low embodied carbon. So here in this graph, we're looking at concrete compared to other typical building materials. And you see on a per kilogram basis, concrete is the lowest, has the lowest embodied carbon of all of these materials. But we make so much concrete each year that we really outstrip all of these others in terms of the amount of total embodied carbon. And so where does all of that CO2 come from? Well, it comes from three different places mainly. You have the process of getting the natural resources, grinding them up and preparing them, and then grinding the cement down to that powder. That's about 10% of our CO2 emissions. You have thermal emissions, which make up about 40%. And to make cement, we have to heat it up to a relatively high temperature. And so we have to make sure that we use proper fuels, but that is going to produce quite a bit of CO2. But the majority of the CO2 actually comes from what we call process emissions. So when we make concrete, we put the raw materials into a kiln, we heat them up, they slowly move through this kiln, and at the end we end up with the cement. We use different fuel sources such as coal, oil, gas, tires, biomass. But during this process, we go through something known as calcination. We have to use limestone to make cement, and limestone is calcium carbonate, or CaCO3. When you heat up calcium carbonate, which is what we do here, you actually break down the calcium carbonate into calcium oxide and carbon dioxide. We need the calcium oxide for the cement, and that releases a lot of CO2. So actually the majority of our CO2 emissions from concrete don't come from the burning of the fuels. It comes from this release of CO2 from the breakdown of the limestone. So how can we reduce the embodied carbon? If we need cement and we need concrete, we make so much of it. Obviously, we sort of need some of that at least. How can we reduce the embodied carbon? And this is all towards moving towards more of a green concrete system, green infrastructure. Well, the main tool that we have, there are others, but we're not going to get into them today because of time, is to replace the Portland cement with what are known as supplementary cementing materials. So these are things like slag, fly ash, silica fume, ground glass. Many of our supplementary cementing materials are byproducts of other industries or produced from waste materials. And so when we use these materials, we can replace a portion of the cement. We can't replace all of it because we need the chemistry of the Portland cement to help cause the reaction of the SCM so that we get a good, strong product. But these are often byproducts. They typically have a low embodied carbon, particularly with the byproducts, because we assume that the embodied carbon is not part of the process for making these, because these are made as a byproduct. They aren't made specifically for this use. Though if you do end up starting to make them for this use, that's a different story. SCMs will improve our concrete properties, and the cost is generally similar to Portland cement. Barriers to use, though, it takes time for new products to be approved by the state. Most states take their cues from the Department of Transportation. So if the Department of Transportation hasn't approved a material, nobody else in the state is going to approve the material. It takes time to get technical understanding of materials out into the world. And there's some liability concerns about using some of these and whether they're going to be safe or not. Most of the time they really are, but people are still worried about it. And then just a lack of interest or support from owners. So the people actually buying the concrete, that, you know, they're not necessarily interested in changing what they're doing. Why does this come down to local government? Well, concrete is local. We make a lot of it locally, but all of the materials are also local. We don't make concrete from aggregates that are shipped in from Montana. They're made down the street, they're quarried down the street. And so here I'm going to pass it over to my co-presenter, Chris Neidl, to continue.
Thanks, Matt. Yeah, so just picking right up on that, because this material, which we look at in global terms, has such a huge impact, it's really important to sort of zero down microscopically on the fact that, again, it is locally produced. And because of that, local governments, which all procure concrete, can have a real catalytic impact on change and transformation and the kinds of concrete they're used in a given area through their own purchasing decisions. Next. And so we have an interesting case right here in New York State, in the tiny village, population 8,000 of Hastings-on-Hudson and Westchester are doing some really interesting things over the last year to really try to focus on concrete purchasing as part of their overall climate impact strategy. Next. And they passed a year ago the Hastings resolution, which was basically just saying, you know, passed by their board of trustees, initiated by their mayor, that they're going to look at the utilization, ways of using or promoting low carbon concrete in their town. It was non-binding, but what we've seen is that this, just the effort of doing this really kind of set the stage for more specific actions. And immediately they began piloting. They did 2 different pilots that summer using different mixes that include some of those SCMs that Matt mentioned. Next. And one of the key things we've discovered is that, as Matt sort of alluded to, is that, concrete is just this universal material that's been around for millennia that is foundational literally to our built environment. So that comes with a lot of sort of caution and conservatism and some sort of resistance to change. And when you're trying to make change, it's not just single entities. It's not as simple as convincing the concrete producer. It's all of the folks at the Public Works Commission, town engineers, contractors. There's a whole chain of folks that have to sort of be on the same page in order for any changes to happen. So you need to overcome this. So you can go ahead, Matt, next slide. So we think about incrementally starting with small projects and experimenting with different forms of low carbon concrete that use some of those ingredients or changes that Matt mentioned. You can go ahead, next. And the best way to do that is to kind of not start with, the Hoover Dam or some large gigantic project, but rather just get a stake in the ground to get everybody sort of oriented around a general goal. So what types of projects are sort of ideal for initiating that learning by doing process? Matt? Sidewalks are perfect. So I'll tell you why. Go ahead, next. One thing is that they're universal. That's a universal form of civic infrastructure that every local jurisdiction is familiar with. They're incredibly simple. It's really just sort of a one mix type of thing. They're low risk and they're low cost. They're not going to fall on your head. If a sidewalk is falling on your head, you have other problems to worry about. And they're frequent. They happen all the time in any given area, which means that each opportunity for a sidewalk is an opportunity to experiment, test, and learn. Next. And so here we're sort of following on what Portland, Oregon did, which has a more comprehensive low carbon concrete procurement strategy. And when they were sort of advancing this, they decided to do some pilots initially for those reasons around sidewalks. So we're sort of taking our cues from Portland out west. Next, Matt. And so the open source sidewalk idea is kind of a way of sort of universalizing the idea of sidewalks in the local context, having this type of impact. Go ahead, Matt, next. And so what we're looking at is that different local places, concrete is local, right? And you're drawing on different materials that are available and that are appropriate given the environmental conditions. So the idea is that can we develop a program that sort of encourages local governments to develop mixes that not only reduce carbon, but don't compromise structural performance. They are appropriate for the local climate. And importantly, they can be locally sourced and they also aren't going to blow up the budget. They're cost effective. So those are the sort of constraints. Next slide, Matt. And to the open source part, if you're familiar with open source, like software development, it's where you publish your code and anybody can look at it, tweak it, and then repost an alternative to that. And that's kind of what we're looking at here is that we start with mixes and almost as though it's source code and publish those so that anyone in local jurisdictions in the same area can look at it, adopt it, but they can also potentially tweak it and republish it. So it continues to evolve in a sort of a crowd-based way. Next slide, Matt. And so what came out of our initial process, we ultimately do want to see if we can create a universal program here because we do think it's very, it can be implemented and tweaked by any local government as long as there's a will. But we started with Hastings, which initiated this process of saying, all right, well, let's figure out what works for us here locally based on those parameters. And we came up with what we call the Rivertown mix over about a 3-month process. And Matt was one of the advisors on that. Go ahead, next slide. And what we came up with was a mix that utilizes crushed glass or ground glass pozzolan as a substitute for cement, either 20% or 40% substitution, which has an enormous impact on climate potential. We like this because there's now 2 local producers. It solves a waste stream problem too, where you can take municipal glass that is increasingly having a difficult time finding its way into recycling markets and use this as actually a material that substitutes the most carbon intensive and expensive part. And we also like this because there had been pilots just right within the same area and third-party testing in New York City by the City College of New York. So we knew it was sort of a known quantity. And so that was what the Rivertown mix consists of. Go ahead, Matt. And so where we are right now is we've developed it. Hastings on Hudson is going to be its sidewalk season right now in the summer. And they're going to be pouring a project, and neighboring Dobbs County is close to making a determination on that. But now that it's a real mix, hopefully with a real project, we want to promote it up and down the Hudson Valley where this type of mix can be implemented as well. Next, just about done. But what after that? So what we do think, again, this is something that could not exactly go viral, but could be something that if there's a will and there's to do it, we could potentially have this spread all over the place. Matt? And so what we're developing right now is basically a mix map where we can potentially provide some guidelines for local governments and activists to pursue a similar type of research project where they can develop locally appropriate mixes and then publish them so that others can see them and use them. Next. And we already have some partners in Ann Arbor developing they're calling the Wolverine mix, which uses some of the locally appropriate and sourceable low carbon materials there. And we actually have another project potentially in Costa Rica and a couple of other places as well. So we're starting to develop a bit of a mix. And last couple slides. And in fact, that is the last slide. So this is, again, right now this summer, we're looking to get the Hastings mix done. But we look, as we get into the fall, to, again, try to promote it more broadly throughout the state, region, and even beyond. So thanks so much.
Thank you both for that presentation. I think it's probably the first time a lot of us have thought about concrete and chocolate chip cookies in the same breath. So much appreciated. For our last, but as I said earlier, not least presentation, we want to welcome Terri Matthews, the Director of Town and Gown NYC, and Jennifer McDonnell, a resource recovery professional with over 15 years in the field of solid waste, recycling, and biosolids management. Welcome.
Thank you. I guess we go to the next slide. Hello. This is the third time Town and Gown has been here. In 2019, we came and we talked about the program as a replicable model of university community partnership. Then last year, Professor Matt Adams presented on one of the projects he was doing with DOT on recycled concrete aggregate. So first we talked about the program, which uses applied research to inform policy. That's what Town and Gown is about. We tend to do a lot of free work, use experiential learning, but we also have a master contract which supports funded research. So Professor Adams talked about recycled concrete aggregate. And then this year, Jennifer and I will talk about the initiative, after RCA and looking at all the loops, we figured that to further the reuse of construction demolition waste, we had to look at how a government, it's very similar to what the Sidewalk initiative is doing. It's where are the points of leverage that a government can use to change the system. So that's what we're doing today. Jennifer?
Yeah, so I like these graphs because they give us a staggering view as to how urban areas really pull resources from everywhere to exist, build infrastructure, and operate. These are three metrics published by Christopher Kennedy and team showing energy use, water use, and solid waste disposal indicators of resource intensity. And you'll notice that New York City, where Terri and I are located, seem to be winning or losing, is probably more appropriate, on all these metrics, having the most intensive resource consumption sort of globally. And as she mentioned, one of our realizations through the Town and Gown collaboration and the construction and demolition waste working groups that have been going on for a couple of years is that there's a lot of construction and demolition waste generated that is not recovered, but might be ripe for recovery. And that's what we're digging into. So urban resource recovery is what we're calling it. And there's some really good data emerging around how important it is to tackle this piece of these pies, so to speak. The Ellen MacArthur Foundation issued a report a couple years ago about the circular economy and really starting to highlight that we've been focused, we meaning the collective approach to addressing climate change, a lot on direct source energy emissions. So combustion of fuels, what types of energy we're using for electricity and heat. We haven't really looked at what they call the second half of the pie, which is consumed materials. So you can see here that if you look at it more globally, about half of the emissions worldwide are from producing things, growing things, land use. So by ignoring this sector, we're effectively ignoring almost half of the greenhouse gas emission sources. So that puts a focus squarely on goods and materials. And similarly, on the right-hand side, the EPA has published data indicating that much like in the energy sector or in the greenhouse gas emission sector, we focus on energy. In the waste sector, I think a lot of the focus has been on municipal solid waste and not so much on construction and demolition waste. And as you can see from these graphs, that's really, again, putting more of the focus in the smaller piece of the pie. So that's where the Urban Resource Recovery Group is going to dig in and start to look at what's in the construction and demolition portion of these pies and what can we do to reduce them by establishing resource loops within the city. So this approach actually aligns really well with a lot of the policy drivers already in place in New York City through many of the recent, meaning multiple mayoral administrations, with the One NYC plans, the Built to Last, the Roadmap to 80 by 50 and 1.5C. These are all policy documents that outline many goals that align with the concept of urban resource recovery. So support there for pursuing these concepts. So this is another visual from the Ellen MacArthur Foundation, who I think is really doing some great work in the circular economy space and with resource loops in particular. And the city has partnered with them on a couple discrete projects, one related to fashion, another related to food. So we certainly see the potential to look to models that have had success around the world as far as how can we replicate them in the city, focusing on loops of materials. And this shows a lot of different loops, but the concept is, right, that you have materials coming into the city and you're able to recover them for further use again within the city.
Hello. So the Closing Loop City program, which was the best I could come up with at the time as a title, came out of all of the work that's been going on in Town and Gown, the Construction Demolition Waste Working Group. We've had events. We're up to the 7th one. We're going to be doing more in the future. But, you know, recycled concrete aggregate, you hear about gypsum, you hear about glass, pozzolan, you hear about all these things. And they are byproducts of the construction demolition waste process, and most of it's going to landfill. I mean, as far as we can tell, and so the question is, how can government, as a large actor, as an owner of construction projects, leverage its systems to close the loops, which would recover embedded carbon, reduce GHG emissions, and we believe generate capital budget savings. We've developed it. This is the first time we've gone public with the idea of it, which is exciting. And we will be looking at soil from demolition, concrete aggregate in the reuse of concrete, curtain wall glass. You've been all talking about municipal solid waste glass, but these buildings that were put up with curtain walls are going to come down. The curtain walls don't last forever. Another topic that came up is near shore dredge. When you're doing water, what do you call it? The seawall, the water wall reconstruction, you have to take out the dredge that's going into landfill. The people at Rutgers have created a pneumatic flow tube technology to allow you to take it out and put it back into concrete to sequester it. Old building components, if you have old buildings, as we do in New York, when you're taking them down or you're renovating significant portions of it, you end up with old wood joists that are currently going into landfills. Last summer, we started looking at wastewater treatment facilities and the biosolids. There are some construction applications, the grit and the biosolids. We're going to look at that. And our latest edition, decommissioned wind turbine blades, which New York is starting. These things, the wind blades do not last forever, but they get decommissioned at a rate faster than their useful life, which means if you want to keep them out of your landfills, you got to figure out uses for them. So this is what we're working on. I hope next year we'll be able to tell you more about it. But it's supported by research and practice, and Jennifer, keep going.
So where we're at right now, in addition to having no shortage of materials that we've identified need to have sort of creation loops, if you will, and we've been strategizing with the members of the town and gown community about how we put those pieces together, the pieces of research and market creation and the technical specs that we heard about in the last presentation. In fact, there's many connections between that, the concrete concept, because we've identified early on, we'll say a little bit more towards the end of the presentation, that specifications are going to be really key to closing some of these loops. But, you know, clearly within the city, and one of the beauties of the Town and Gown program is there are many agencies that have significant capital programs. I'm representing one agency, but there are many other agencies in the working group, DOT, DOE, DSNY, parks. There's many agencies who are building and using these types of materials with a significant budget, obviously. Below that, there are thousands of contractors and hundreds and thousands of suppliers. So we're really trying to figure out how we bring those parties together. And it's not helped by the fact that there's really a dearth of data on the construction and demolition waste and where it's going. So that's another project that Town and Gown is actually working on right now with some students at a couple of the schools within the city to look at the flows of construction and demolition waste based on data that is required to be reported to DEC, but is not digitally compiled currently, nor is it easily accessible from a reporting perspective. So we're taking a look at that as well. As Terri mentioned, these are some of the ideas of where we're trying to build loops. We looked at that same picture, I think, of the glass already, but the soil, year round, that's a big picture up there of dump trucks from the agency that I work at, DEP, actually doing, work in the roads, water and sewer work. So they're able to reuse soil because the Mayor's Office of Environmental Remediation actually opened a stockpile site in the city this year. It was big news to have a place to park soil that could be reused rather than the truck in, truck out model that was relied upon for most construction. And then other programs, even the co-digestion of taking food scraps at the wastewater treatment plant as ways to close loops within the city. So there are some existing frameworks for this type of resource recovery. For those of you who are familiar with the LEED program for buildings, there's a similar program called Envision, if you haven't heard of it, for infrastructure. These programs, are very prescriptive. They give you specific guidelines and how you get points and how you score your building from sustainability measures. But although many agencies use these programs, it's still subject to the ultimate contractor's means and methods as far as achieving the design or enlisting the materials, finding the materials, making sure things get recycled. So it's important for those executing the projects to have SOPs and guidelines to make sure that those prescriptive policies are put into place. So this is an area that I think the city's made some progress, but there's still an opportunity to have more visibility and make sure that these are supporting the closing the loop idea. Another project actually that Town and Gown is working on is understanding the regulatory structure around the state's solid waste rules and how they relate to material flows. So DEC has jurisdiction over these materials, and they have a policy framework called beneficial use determinations, that's what that BUD stands for, that allows a material to be qualified for reuse and exempt from the treatment as a solid waste, but you have to obtain that determination, the beneficial use determination, in order to reuse a waste material. So there is a supportive framework, and one of a cohort of Brooklyn law students is doing a policy memo this summer to try to help illuminate what can be a very confusing piece of policy that is there and needed to support the material loops. And finally, there's the private sector that's already doing some of this. There are material recovery facilities for construction and demolition waste. Cooper Tank in Brooklyn is a state-of-the-art facility that is taking in mixed loads of construction and demolition waste, sorting them into different sort of commodity components and trying to find reuse markets for them. And then direct reuse, that's very dependent on timing. Terri mentioned like the joists, and I mentioned the soil pile, but finding spaces to align project timing for these types of direct reuse is clearly one of the biggest challenges in an urban environment.
So for a minute, I thought I had forgotten to talk about this, and then I realized it was here. What we've done is learned, to do this, every material loop has to be investigated separately. So there's no one silver bullet, but there's a process. If a local government wants to leverage its public processes, it can apply it to each material separately. From a public administration perspective, the way we're looking at doing it is data analysis for savings estimations and CDW flows. Problem with that, at the agency level, we are not keeping construction demolition waste data in a usable form. LEAD doesn't do a very good job. The data reports are buried. The state, on the other hand, has this reporting system, and we have an NYU CUSP project to use that. It's PDF'd, and we're actually doing manual data entry so that they can create a data visualization tool. But data analysis is important. And we're working on that. Material specifications is a big problem. And Matt alluded to it, and I think it was the second one. But the state of New York is working on template specs that the state will be using and that other local governments can use. So that is a good model to follow. But the big important thing is if you do an initiative, you don't want to increase construction prices because you're doing this initiative. And because we're procuring services in a low bid way that is subject to a construction contract, you want to support the contractors you've hired. If you want them to do something differently, you have to figure out a way to make it so it doesn't harm them. It doesn't increase prices for them, reduce profit, or increase schedule delay. So the first thing is you need a virtual connection platform to speed up the generation, where the stuff is available and where it can be used. In Europe, they have some of these, they call them dating marriage sites. It's literally, here it is. It's available for like 3 minutes here because you don't want to screw up your schedule. And a contractor could say, oh, I could use that. Now, this is all subject to the buds. You can't reuse things that don't have the bud designation. So we want to have a platform to support all of this, but we also want to change some of the city construction provisions to, while we're beginning this, just share cost savings, not forever, but at least at the beginning, and introduce data reporting requirements. And then for the interim processing plants and the manufacturing facilities that can take the CDW and turn it into a higher value construction product, you need to think about manufacturing and the private sector investment in manufacturing facilities, which can be local or near local. If it is local, meaning New York City, you have the New York City Industrial Development Agency, which is a federally subsidized program where the interest rate is subsidized by the federal government. And so we're looking at, you know, that prong as part of what everybody calls the circular economy, because if you do this, there will be opportunities for businesses to get into the interim processing and the higher value manufacturing. So I'm done.
Great, thank you both. Oh, I'm sorry, Jennifer, did you have something
Oh,
else?
no, I mean, this is basically summarizing what Terri said. You know, we think we know the next steps. This is a pretty tricky loop to try to put together in the context of the city. But right now we're working on the disparate pieces and hoping to find the ways that connect. And we anticipate that it'll be through projects like the low carbon concrete that we're able to have some successes and really demonstrate a model, and then hopefully replicate the concept, but obviously with the components being a bit different as you move into different material flows. So, you know, I think these core pillars here are going to apply no matter what type of material we're trying to close the loop on. And maybe we didn't emphasize it enough, but, you know, in addition to generating a lot of CDW, the city is a very large buyer of many of these components. So it really is about trying to make the two sides connect.
Great, thank you both so much. I want to thank all of our panelists. Unfortunately, we're out of time for question and answer, but we can follow up individually if folks want to put things in the chat. I'd just like to thank everybody for their participation today. You all have given us a lot to think about, and I think in the context of ongoing federal discussions about infrastructure plans and potential funding that might filter down to the local level, there's a lot here to think across scale about as well. So thank you for that, and thank you all for coming today. Have a wonderful day.